So let's get started. Over to you, Himanshu.
Thank you, Pranisha. Yeah, can you confirm the PPT is visible?
Yep.
Yes.
Okay. So, am I visible?
No. Yep. Yep.
Great. So, hello everyone and welcome. I'm Himanshu and I'm excited to guide you through the fundamentals of networking on AWS. Today, we are going to demystify the cloud networking and understand how to build a solid foundation for our applications on the cloud. Previously, we have studied about various services, for example, compute services like EC2 and storage services like S3 bucket, etc. But to set up the infrastructure, we need to have the knowledge about networking on AWS. And in this session, I'll be using a fun analogy of building our own cloud building or cloud office. And we'll be using that analogy to understand the various concepts on networking on AWS. So let's get started. So here's what we'll be covering in the next hour or whatever 45 minutes. First, we'll be quickly understanding why networking is so important in AWS. Then we'll introduce our office building analogy, where first is the VPC. VPC is basically will be our own entire building. Then we'll move towards subnets. Subnets will be basically the rooms in the buildings. There are various kinds of rooms, for example, meeting rooms, then server rooms, etc. In our building. So the rooms will be referred to as subnets. Then we'll be moving towards basic networking configurations. These are the infrastructure required to set up our office. Then route 53. Route 53 is a service, DNS service, which is provided by AWS. DNS is a domain name service. I'll be covering about it further, and we'll be putting it all together in a simple web hosting scenario. So how all the networking flow works, we'll be covering it at the end of the session. So why is networking crucial in AWS? First, what is networking? Networking is basically connecting compute devices over a network which can share resources and communicate with each other. And for sharing resources, as we know, multiple protocols are used over the internet. For example, TCP/IP protocol, UDP protocol, HTTPS, then DNS, DHCP, etc. So this is networking. Now, why is networking crucial in AWS? Like as what is specific related to AWS? So for AWS, think of it like the foundation of a building. Like without a strong foundation, nothing else works properly. So AWS networking is the foundation of our infrastructure. Uh, then it will be covering, or rather we'll say connecting our resources or instances. For example, we have an EC2 instance, so it will be the foundation to connect our EC2 instance to the entire service. And the next property, security and isolation. So networking is important to secure and isolate our data basically. For example, business logics and business data are very crucial to the company, so they need to be secured, and as well as they need to be isolated from the normal public usage or normal from the people using AWS. It should not be directly accessible. Next is scalability and flexibility. As suppose a business is growing and now it wants to scale further, so the scaling should be easily and smoothly. So this is one of the most important feature where networking in AWS plays a crucial role. Next, cost optimization. If we do efficient networking analysis, and if we do manage our networking infrastructure properly, we can actually save our money. As we know, it is a pay as you use pricing, and if it is not used properly, so and configured properly, we can have like large losses. Like there was one of the instance where EC2 instance was let open, and there's a saying that free flowing river of money, it was basically. And then for this, we'll be using the analogy time, that is building our own office. So let's get started with building our own cloud office. First, VPC will be our own building. So the building of our office, which will contain various resources, we can manage from a person goes to this room or something like that. For example, a server room should not be accessed by anybody else in the building. So there need to be some access specifiers for that server room, like that, etc. So this all will be placed in entirely in our VPC. So VPC is an isolated section or a building. Uh, so in this section, we'll have multiple things. First is subnets. The subnets will be our rooms. Rooms can be of various purposes, and rooms can be we can have multiple instances placed in our rooms. So like configurations will be placed in one subnet, and we can have multiple subnets in our own VPC. So one building can have multiple rooms. Similarly, one VPC can contain multiple subnets. Next is the internet gateway. Now we have set up a building, we have rooms in it, everything, but how to connect it? There needs to be some connection, right? So the internet gateway is the thing that connects our VPC to the internet. So we can means like we can imagine a road which will connect our office to the entire city or something. So internet gateway can be referred as to the road which connects both internet and the VPC. Next, security group and NACLs. These are basically protecting our resources and controlling the access. Like our data cannot be should not be accessed by anybody else. Only it should be accessed by the people who are in the list. So let's say I have a conference room, and in conference room I have a list of people that only these people can access this data, or these people can enter in the room. So this is managed using the security groups and NSLs. Now, the VPC. VPC is our building as we know. So it's the logically isolated section of the cloud. Think of it as renting an entire floor of the building in a co-working space, or simply setting up an isolated section. So in this isolated section, what is exactly happening is this is our own private space, and we'll be like using setting up multiple things in this office or in this section. So first thing we can set up is controlling our network. So we are in charge, we are setting our own office. This is entirely up to us how we set up this office. So first is controlling our network. You are in control. You define the IP ranges, you create the subnets, you set up the routes, and you manage the network gateway within our VPC. Okay, so you are the architect of your cloud office. Next, isolation and security. Crucially, a VPC isolates your resources from other AWS customers or users, etc. This provides a fundamental level of security, and it provides prevents sorry provides not prevents accidental data spillage or accidental interference from other people. uh, Next, why is VPC essential? So we know how to build our cloud office. So here we will be we built our cloud office, but why do we need to do this? Okay. So first and foremost, isolation is the key for security and privacy. To keep the data secure and private, we need to have isolation. To prevent accidental exposure of our resources, isolation is the most important thing. Imagine like for in our office, sharing our office space with strangers, like it's not an ideal situation in a business, no. Like we have some sensitive data, so it should not be spilled over to some strangers. Next is customization. You can customize almost every aspect of your VPC, from defining your IP ranges to setting up complex routing and security policies. Everything can be customized in your VPC. So as I said, you are the architect and you will design your own building. So in our building, like we can choose how to place the address name, for example a company's name, then say XYZ area and something. So we can decide how to set up that is customization. Next is data security. With control comes the ability to implement security measures. tailored to the specific applications. So you can define your specific security rules and access controls within VPC. You can decide who gets to access the data. That is data security. Next is control. Having VPC gives you full control over your network environment. You can customize, as I said. You're not restricted to a shared generic network setup, and you can design your office layout exactly how you want it. That is the control that VPC provides you. Next, we move towards key features of VPC. So let's touch upon some of the characteristics of VPC. First is the CIDR block. What is a CIDR block? When you create a VPC, we define a range of IPs, that this range of IPs should be allowed or something. Uh, while building your network, try putting it as 0.0.0.0. Just kidding. It's the global IP address. Anybody could access you. Refrain from using 0.0.0.0. Okay. So CIDR block is basically a directory in which you can mention which IP addresses should be allowed, and how, means number of IP addresses, and you can specify their usage. Uh, it can be from one IP to a range of IPs. Next, regions and availability zones. VPCs are regionals, means they are tied to a specific regions. If you have seen the AWS console or something, we know that there are multiple regions separated. For example, we have Mumbai and then Bangalore, etc. So you can have those regions, and the VPC spans over multiple availability zones. Next, there are two types of VPC: default VPC and custom VPC. When we are setting up a VPC, the by default with configure means like previously defined configurations is the default VPC, but you can customize your VPC. So customizing your IP, then uh, like adding something that's not in the default, basically it's the custom VPC. So we'll be first having a question on what is a VPC. So what is the main purpose of an AWS virtual private cloud or a VPC? Answer in chat box.
स्पेलिंग वेगळं आहे. अप्सरा अप्सराली मला नाही वाटत दिवस वगैरे असते.
Okay, great. So to create an isolated network within our AWS, we use the VPC. Next, moving towards subnets. Now we have set up our own office. Now we had to add rooms in it. So subnets are the various kinds of rooms that will be set up in our office. These are the subdivisions of VPC. Subnets divide our larger VPC IP addresses into smaller networks called subnets. What is the purpose of subnets? Subnets are used to organize resources based on functions, security needs, then availability requirements. Think of different rooms used for different purposes. For example, some common rooms like the reception room, etc., which can be accessed by anybody, whereas some secured rooms, for example, server rooms. So server rooms would be analogous to your databases. Like databases should not be accessed by anybody directly. No. Similarly, server rooms should not be accessed by anybody else except the specified people. Next, availability zones, a crucial point, that subnets are always within a single availability zone. Similar to VPC, you can't have a subnet spanning to multiple availability zones. Each, for example, our room is located in a specified part of our office building. No, uh, a room on the ground floor cannot be accessed directly from the fifth floor. Similarly, a subnet should be cannot should sorry a subnet is always accessed within a single availability zone. Next, there are two types of subnets: public subnets and private subnets. We'll be covering deeper in the further slides, but just to give a gist, public subnets and private subnets. The public subnets can be directly accessed, whereas private subnets have some specifications, some security rules. Yeah. Public subnets. So this is like your front office. This is directly accessible from the internet. So what is public subnet? It is directly connected to the internet. It is a resource in a public subnet that is connected to the internet. They can be directly accessed. Like if you allow with security rules, they can be directly accessed through the internet. They do not have some specified rules. Uh, only like you access. Suppose a user puts in a request, so anybody can access through that. For example, a front end of a website, can be directly accessed by you if you put your request. If there are no like what we can say is like resistance set or something like that, security set, so you can directly access the front end of a website. No, similar to that, public subnets can be directly accessed. Next, internet gateway. Public subnets are public subnet is associated with an internet gateway. Internet gateway, as I've told, is a like it's a connecting path between internet, normal internet, to your VPC. I'll be explaining about internet gateway further. Next, what is the typical use case of a subnet? Like why do you need a subnet? So things that are directly accessible from the subnet, things that should be directly accessible from the internet are placed in the public subnets. For example, web servers, then load balancers, etc. That basically anything that needs to handle public traffic will be placed in the public subnet. Next, private subnets. Private subnet, as I said, is the your server room. It is not directly connected to the internet, and it cannot be directly reached from the internet by default, and vice versa. By default, they cannot access the internet directly. They have some security measures. So, second point, enhance security. This makes private subnets ideal for sensitive resources that you don't want that you don't want to directly expose to the internet. For example, your databases, application servers, business logics. These are your critical and confidential resources, right? So these are placed in private subnets. Next, so if I cannot access the internet directly, so how do I access this? So the private subnets access internet indirectly using the NAT gateway. So we'll be touching on NAT gateway if time allows, but basically uh, NAT gateway will be like NAT gateway, we can say, how do I put this in simple words? Okay, so basically it's a network address translation in private subnets. Like uh, we can say this as a mail room. Like from the server room we need to connect something, so we'll have a mail room which connects the uh, public resources from and the private resources. We'll have a between communication, so we can refer it to as a mail room. Then typical use cases of a private subnets can be database servers, application servers, backend systems, etc. So these are the key differences of the public subnet versus private subnet. First point, internet access. Public subnet can directly access the internet via internet gateway. Private subnet cannot directly access. It's the indirect access via NAT gateway or by creating some instance. Next, accessibility. Public subnets are accessible to the internet if you configure security rules to allow it, like the front office being open to visitors. Similarly, then private subnets are not directly accessible from the internet, like the server room being logged. Next, the security level. Public subnets are inherently less secure because they are exposed to the internet, and private subnets are more secure by default due to their isolation. Next, use cases. Security level. Public subnets are inherently, no, I've covered this. use cases. Public subnets are for public facing components like web servers and load balancer, and private subnets use the backend are for backend components like databases, application servers, server room, internal operations, etc. So second question, in AWS, what is the key difference between a public subnet and a private subnet? Okay, great. So the public subnets can access the internet directly, while the private subnets cannot. Moving further, basic networking configurations. Now, setting up our own office infrastructure. We have VPCs, that is the building. Now we have subnets, that are the rooms. Now we need to equip our cloud office with the essential infrastructure to make it functional. So let's have a look at some key networking components. First, IP address. IP addresses are analogous to office addresses. Just like every office needs address for mail and internal routing, we need IP addresses. We have private, public, and private IPs for communication. So the private IPs are used for internal communication, whereas public IPs are used for external communication. Then route tables. Route tables gives the directs the incoming traffic to your website. So to direct office within to direct traffic within our office and the outside world, we need route tables. These are like traffic signs, like go this way and something like that. So route tables will be directing the traffic that comes to the website. Next is the internet gateway. Internet gateway is the main road to the internet, or rather main road to the connecting our building to the internet, allowing our VPC to connect to the outside world. Next, security groups. Security groups. Now imagine this as room security guards for security at individual room level, or let's say instance level. For example, we have an EC2 instance or a S3 bucket instance. So we need to have security for it. So these are instance level firewalls, uh, which will be analogous to a room which has a security guard outside. Next, network ACLs or NACLs, we refer to it, and NACLs. So these are like subnet level firewalls. So this will be more like a security guard to the entrance of a building, not to the entrance of a room, but to the entrance of a building. So these are network ACLs. Next, IP addresses. So IP addresses are, or office address. There are two types: internal and external. We'll deep dive into this further. First, private IP addresses. These are used for communication within our VPC and subnets. Think of them as internal room numbers within our office building. So like in our college, we have room numbers, say 3101 and something. So private IP addresses are basically room numbers for our building. They are assigned by automatically by AWS, or we can specify. As I've said, it is customizable, totally customizable. So we can customize our room numbers, or say private IP addresses. Next, public IP addresses. These are used for communication to the outside internet. Think of them as a street address of our building, allowing external communication. They are assigned by AWS and associated with resources in public subnets, but these are optional, like not mandatory, but these are optional. Next, elastic IP addresses. Elastic IP address is a concept. Basically, these are static public static public IP addresses, which we can allocate and associate with our instance. Think of them as a reserved or permanent street address for our building. If we need something like a reserved address for our building, that does not change, so we can use elastic IP addresses, and again these are optional. Next, route tables. Now we have to direct the incoming traffic to our website with some specifications. So these are the guiding network paths for our website. So what is the feature or functional of route tables? So route tables control the traffic flow. Route tables determine where network traffic is directed. They act like traffic controllers for your data packets. Some data is coming, so they route or direct the data where it needs to go. Next, subnet association. Each subnet is associated with one route table. This route table dictates how traffic from that subnet is routed. So let's say some traffic is coming to a specific a subnet. So the route table will decide where that traffic should be routed or directed. Next, route table. Now we have route tables which direct the traffic, but how are these routes placed? So the route table contains routes which are rules to specify the destination and how to reach them. So like we have signboards that 500 meters turn right or something. So these are the rules. Routes are basically the rules how the traffic should be directed within the VPC or outside VPC. Then there are two types of route tables: default route table and custom route table. Again, every VPC has its own default route table, but we can also customize them. And majorly we have to customize the route tables to have granular control over routing for different subnets. Next is the internet gateway. Now the internet gateway is the main road to the internet. I've mentioned it a few times, but like let's focus on the internet gateway. So VPC is gateway to the internet. What is an internet gateway? It's the gateway to the internet, simply, nothing else. Through the internet gateway, information can go in and go out. So it's the connection. Now it is horizontally scaled and redundant. AWS manages the internet gateway and makes it highly available. It's horizontally scaled and redundant, so you don't have to worry about its reliability. Basically, attached to VPC, like you have to specifically, or like we need to attach we need to have some opening door in our building, right? Similarly, we have to attach an internet gateway to a VPC. So if suppose we have multiple VPCs, so we'll have to attach internet gateway to each of the VPCs wherever it is required, like adding doors to each of the rooms for information going in and out. And then internet gateway is essential for public subnets because this is the internet gateway. Without an internet gateway, public subnets cannot be truly public and reach the internet, right? Next, security groups. So security groups are instance level firewalls. These are like room security guards. For example, we have an EC2 instance, so we can control the information going inbound and outbound traffic, basically. And other network resources like network interfaces can be controlled and guarded by instance level firewalls. Next, stateful firewalls. Security groups are stateful firewalls. This means that they remember the allowed connections. If you allowed inbound traffic on a certain port, the outbound response traffic is automatically allowed back. Okay. Then there are allow rules only. Security groups are allow lists. You explicitly allow traffic. What this means is, if something is not explicitly allowed, is denied by default. It's like saying only people who are on the list can enter this meeting room. Then these are applied to instances. So like we can associate the security groups to any of the instances which we want to have, and each instance can have multiple security groups applied to it. Okay. Next, network ACLs or NACLs. These are building security guards, not just a subnet level, not just instance level firewall, but this is an entire subnet level firewalls. So NACLs act as a firewall at subnet level, and they control the inbound and outbound traffic for the subnets. Uh, Stateless firewall. So NACLs are like stateless firewalls. They don't remember connections. Rules are applied to packets coming, like we have data packets. So rules are applied to data packets, both incoming and outgoing, and we need to explicitly allow both inbound and outbound traffic needed. For security groups here, in security groups, the inbound traffic allowed was implicitly outbound traffic was also allowed. But in this, we need to explicitly mention inbound traffic rules as well as outbound traffic rules. Next, we have allow and deny. Okay, allow and deny rules. So allow and deny rules are like traffic rules which can give you more granular control over your security. Next, these are applied to subnets. As I've said, this is not instance level, but this is applied to an entire subnet. So each subnet can have one NACL only. Like we had multiple security groups per instance, or per instance. For example, say EC2 instance, we can have multiple security groups, but we can have only one NACL per uh, like per subnet. And there are similarly there are default NACLs as well, as if we need some customization to it, we can have customization as well. So next question: which of the following is not a feature of an Amazon VPC? Okay, great. This was a simple one. The first three belong to the Amazon VPC, and the fourth one does not. Moving forward, Route 53. Now we have set up our office, and infrastructure is also set up. Now we need to make it easily accessible or easily findable on the internet. So we need to have some address directory, right? So Route 53 is Amazon's AWS domain name service. Now, what is a DNS or domain name service? For example, if you type www.google.com on internet, so how does it work? It basically searches for a server which corresponds to the www.google.com. Like google.com might have might not, it obviously does have its own server, and that server has some specific IP address. Now www.google.com, your computer sends a request asking for the IP address of google.com, and it receives it, and then a connection is established between your PC and to the server of Google. So this is basically an overview of domain name system, or DNS. Now, what is Route 53? What is Route 53? Route 53 is AWS own domain name service. Next, what it does, it translates domain name IP addresses like a phone book or a directory, and it translates your like user friendly names. What he has mentioned, this is, for example, www.yourwebsite.com, to the IP address that the computer understands. Like computer does not understand this, it understands something like 192.0 point something point something. So the Route 53 basically translates that domain name to the IP addresses. For example, if we have an A route or something, so the A route translates your domain name into an IPv4 address. Next, what it does is it connects your users to your application. When someone types your domain name on the internet, Route 53 is responsible for directing that internet traffic to your to the correct IP address of your resources, like web servers running in your VPC, etc. Then Route 53 is highly available and scalable, and as it is managed by AWS, it is you don't have to worry about DNS servers yourself. AWS takes entire care of it. So for analogy, this is basically an address directory for your office building. It lists your office building name and points people to its location. Next, what can you do with Route 53? So Route 53 first and foremost uses DNS management. You can manage all your DNS records for domain names, things like A records, CNAME records, MX records for mail, etc. So this is where you configure how your domain name translates to IP addresses and other services. Next, traffic routing. Route 53 also provides advanced traffic routing capabilities. We earlier read about route tables and how they direct the traffic. Similarly, Route 53 also provides advanced traffic routing capabilities. We can use route traffic to uh, we can route traffic to different resources based on various criteria for say latency based routing, or distribute to the closest server geographically. Like for example, a user in India should be directed to its nearest server, say Mumbai, and not to some server in Ohio. Then health checks. Route 53 perform health checks to monitor the health of our applications. If it detects unhealthy resource like a failing web server, it can automatically route traffic away from it to healthy resources. This is crucial for ensuring website availability. For example, if one server goes down, the Route 53 automatically directs the traffic to the other possible healthy server. Next, domain registration. Like we can have our domain registration directly in Route 53. We don't need to go to some other domain registrar, say GoDaddy or something. Next, Route 53. How Route 53 will be used in our website, which we host in our VPC. So let's say we have a web you have a website hosted in on EC2 in public subnet, on your public subnet, and we have a web server running on EC2 instance in our public subnet. Then we have a domain name, example yourcloudoffice.com. Let's assume you have registered a domain like this, and this is the name people will type to find you, like www.google.com. So this is the domain name. Then in Route 53, we you create a hosted zone for your domain to manage DNS for your domain. In Route 53, you need to create a hosted zone. Think of hosted zone as a specific section. Mm, huh. So think of hosted zone as a separate section in Route 53's address directory dedicated to your own domain name, specific domain name which you have. Then you have name, then you have the you create a record. Like there are multiple address record types, for example a CMake, etc. So we create an a record, then value of our elastic IP address if applicable, like public IP address or elastic IP address, whatever the IP address we have to add its value to the a record. Next, when somebody types www.yourcloudoffice.com in their browser, Route 53 will resolve your web server's IP address to the user, and the traffic is directed to the web server in your VPC. Next question: what is the primary function of Amazon Route 53? Yeah, right. So the primary function of Route 53 is to manage and route traffic for domain names. Next, putting it all together, like whatever we have learned, like, let's put it into a website hosting scenario. So first we'll register a domain name, for example yourcloudoffice.com. Think of this is like a name for your office building. Then you set up your Route 53, create a hosted zone for your domain list. This is analogous to listing your office in the public directory. Then we create a VPC. Uh, VPCs are building. Then we create a public subnet. We create for uh, accessing it through directly to through the internet. We create a public subnet. Then we have a private subnet which contains a crucial information, for example database servers. It is analogous to the server room. Next, we have an internet gateway. We attach the internet gateway to the VPC for internet access. Now next, route tables. We configure route tables to direct traffic appropriately. Then we have security groups. We configure security groups for security at the instance level. Then we have NACLs for security at the subnet levels. For example, security groups here configure for web servers like allow HTTP, allow HTTPS, and database server allow database port from web servers. Then we place web servers in public subnet, databases in private subnet, and then you deploy your your web and database servers in the respective subnets. So in Route 53, we create an A record and finally, uh, like A record basically is record points your domain has to the public IP. This is the step which we can connect your like in office scenario. This is the step in which we can connect the office name to its location and make the website accessible from the internet. So this is a general architecture. This diagram shows how users like reach the website. So first a user sends a request. This request is directed to the Route 53. User types some website address. Request goes to the Route 53. Then Route 53 finds the address, searches in the address directory, and then it points like user sends a request to Route 53. Route 53 searches in its address directory. Then Route 53 resolves the request and it sends it to the public IP that is available. Traffic goes via the public IP to the internet gateway. Now the internet gateway being the front door of our VPC is the entrance. Here we uh, enter in our building. Then internet gateway connects to the VPC, that is to the web server. For example, front office, that is a web server. Then in our VPC we have web servers in our public subnet. Then these web servers can query to the private subnets which have some DB database instance, a database server instance, for example RDS, or some compute instance, say EC2. And this is how the request from a user is resolved uh, in the AWS networking architecture. Thank you. That's all from my side.
Okay, nice. Thanks a lot. We are open to questions again. Yeah, if anyone has questions, go ahead. Put it in the chat box. All good then? Okay. Any sale do you want to explain? Goal say, Himanshu? He has the same name as me. So, you know, uh, okay, I'll be telling you a little bit NACL, then goals we can be continuing. So NACL is network access control list. Okay. So whatever network you have, you can have a list onto who can access it. Okay, so like naam hi bata raha hai tum log ko what it means. Okay, so that means like you can have a list that is specified to your network, and you can say ki bhai only these networks can access my network, or else other networks can't. That is a basic idea of network access control list. Okay, what is the difference between instance level and subnet level? ठीक है, so कैसे रहता है, you have your subnets basically. कैसे रहता है, तुम लोग का एक नेटवर्क रहता है. ओके, नेटवर्क इज योर यू नो वही अभी बिल्डिंग का एग्जांपल लेते हैं. ओके, सो यू हैव योर कंपनी. जो कंपनी का वॉल्स रहता है वो नेटवर्क रहता है. ओके, कि लाइक यू आर सेइंग यू रिस्ट्रिक्टेड, कौन अंदर आ सकता है कौन बाहर आ सकता है. एंड वो जो बिल्डिंग है, द बिल्डिंग इज द मेन थिंग, राइट? दैट इज द इंस्टेंस बेसिकली तुम लोग का जो भी रहता है. इफ यू वांट टू टॉक इन टेक्निकल टर्म्स, हाउ इट मीन्स इज basically you have an application running. Okay, your application is on instance level. Okay, and you say कि मेरा application is running on this port and this IP. That is the network level. ठीक है, so वो network level के अंदर रहता है instance. Okay, so that is what instance and network level रहता है. And if you like if you paid attention, security, you can apply security to network level also, you can apply security to a subnet level also. So instance level पे we have security groups, right? That is on instance level. And on subnet level, that is the network level, you have the NACL. Okay, that's the difference. Route table. So basically, route table, what it means is um, now the like you have subnets. Okay, तो तुम लोग के पास suppose ऐसे समझो तुम लोग का application है, you have two public subnets, two private subnets. Okay, so now these subnets are present in your VPC. तुम लोग का VPC में ये ऐसे subnets present है. So let's say एक example लेते हैं again. बिल्डिंग का ही लेते हैं. सो बिल्डिंग इज योर VPC. ओके, एंड बिल्डिंग के अंदर तुम लोग के 4 रूम्स है. ठीक है, तो 4 रूम्स में 2 रूम्स पब्लिक रूम्स है एंड 2 रूम्स प्राइवेट रूम्स है. एंड वो प्राइवेट रूम्स मतलब यू कैन से नॉट एंट्री फॉर हम लोग बोलते हैं एम्प्लॉइज को एंट्री नहीं है, जस्ट द प्रोफेशनल्स को. तो वैसा कुछ तो समझ लो. ओके, एंड नाउ हाउ विल अभी जो इनकमिंग रिक्वेस्ट आता है ना, अभी सपोज तू एज अ पर्सन, Mayank was asking, right? So Mayank, you as a person would be coming in, right? उधर तो देखो कैसे समझेगा कौन से रूम में जाना है. 4 रूम दिख रहे थे को, तो you are seeing 4 rooms, and where do you want to go? So that is what a route table does. Route table tells कि भाई देखो बस इधर जाना है, ये 2 रूम में ही जा सकता है तू, these are private rooms, you can't go in these rooms. So that is what route table is about. Route table helps you to route the incoming packets, incoming requests to the exact location where you want to get it. Okay, in security group, what is stateful firewall? So stateful and stateless, let's not go too much into it. वो बहुत complicated concept है for you beginners to understand. There is a whole new concept for that. Like वो बहुत ज़्यादा I guess just चाहिए तो like you can say the एकदम इजी वर्ड्स में बोला तो जो इनबाउंड एंड आउटबाउंड हम लोग देखते हैं ना, इनबाउंड एंड आउटबाउंड ट्रैफिक, वी सेट इट ऑन सिक्योरिटी ग्रुप्स, राइट? So we can change the state out of it. So like basically, if you want to change a state onto depending on some request, you can change that state, and तुम लोग basically inbound and outbound change कर सकते हो. Kind of ऐसे समझ लो. Okay. तुम लोगों ने stateful and stateless React में किया है किसी ने? अगर किया रहेगा तो kind of same concept समझ लो, वैसे ही है. वो बहुत like deep में जाएगा. Let's not go into that deep for you freshers or college students to understand. Anything else? How was the session, by the way? कैसा लगा? Also, also you guys can unmute, right? Like तुम लोग yeah, messaging is also fine, unmuting is also fine. Up to you. Okay. Nice. Nice. I can understand thoda bore ho jata hai, you know, you're doing sessions and sessions and sessions. So tomorrow would be the last session anyways. Tomorrow would be the last session and then you'd be starting with the hands-on. Okay. Tomorrow's session would be given by me. So meko bhi bata dena how it goes, you know, on its responses. And yeah, after that session, basically you would be, you know, full on prepared to start with hands-on. And hands-on pe we'd be seeing how will we be deploying websites. Three ways पे कैसे deploy करोगे. One would be S3. So अभी you guys studied about S3, right? So S3 तो storage था, तो storage पे कैसे host करोगे? You know, it's a very you know, weird question, right? But like, yes, you can host your websites on S3. We'll be studying through S3 first. Second would be AWS Amplify. So basically, you heard as platform as a service, right? So ये जो भी services सीख रहे हो तुम लोग अभी, these all these services, EC2 था, EC2 is a infrastructure as service, क्योंकि तुम लोग को direct infrastructure मिल रहा है, right? तुम लोग को पूरा setup मिल रहा था, you know, basically the whole तुम लोग RAM वगैरह सब कुछ change कर रहे सकते थे. Then when you go और कौन सा एग्जांपल दे सकता हूँ. लैम्डा बोला, लैम्डा इज अ प्लेटफॉर्म एज अ सर्विस. तुम लोग को लैम्डा को बताना ही नहीं पड़ता कि हम लोग को इतना कैपेसिटी चाहिए, यू नो दैट. उसमें क्या करता है वो ऑटोमेटिकली मैनेज करता है. सो बेसिकली वील बी सीइंग डिप्लॉइंग वेबसाइट्स वैसे ही. सो पहले S3 पे देखेंगे, then उसके बाद we'll be seeing on AWS Amplify, that is a platform as a service. So basically you don't need to provision any you know EC2 instances. कुछ नहीं करना पड़ता तुम लोग को. You just have to upload your code, it will do all the work for you. That is Amplify. And then third will be seeing through EC2s. So अभी हम लोग डिस्कस कर रहे हैं, right? EC2 पे हम लोग होस्ट कर सकते हैं, then load balancer लगा सकते हैं. You know, there would be a lot of things you have heard. अभी RDS सुना है तो maybe RDS से कनेक्ट कर सकते हैं या DynamoDB से कनेक्ट कर सकते हैं. So वो हम लोग करेंगे. So अभी it's fine. एक दिन सहन कर लो, उसके बाद we'll be starting with the hands-on. And again we'll be having a quiz at the end, 7 day को. And we'd be having prizes for the winners. So uske liye also, you know, look forward to it. Again, about the tags, you can, you know, tag your learnings on through the hashtag that is given, AWS CCPICT Challenge 2025. And if you guys have any queries in general also, कि like मेरे को समझा नहीं, okay, about anything, you can put it in the group itself. You know, don't worry. The speaker who was there or myself, I'll be reaching out to you guys and helping you guys out with any of the doubts. Okay. Okay, Pranisha, over to you.
Yeah. Thank you, Himanshu, for breaking down AWS networking in such a simple terms. Guys, do you have any questions for today's session or any improvements? You can suggest in the chat
Yeah.
or you can
अगर
unmute
कुछ
yourself. हाँ.
अगर कुछ चाहिए एक्स्ट्रा तो बता दो. Yeah, we'll be there to help you guys out, you know, arrange that.
Yes.
Yes. Is it only for PICT students? No, the WhatsApp group is
No.
open for everyone. You don't have a link here? I'll be sharing it maybe.
Yeah.
Discussion.
So any other questions? Okay, so let's move forward. Don't forget to share your takeaways from today's session on social media using the hashtag AWS Learning CCPICT Challenge 2025. You can also see that hashtag I'll be presenting. Just a second. So yeah, you can mention your by tagging AWS Learning CCPICT Challenge 2025 and share your experiences on your socials. So now, thanks for tuning in today. Stay tuned for our tomorrow's session. It will be last theory lecture, and after that, we'll be giving you hands-on with the different things as Himanshu mentioned. So, all right, everyone. Yeah, we can end up for today.
Yes. Thanks a lot for joining. Yeah, see
Yeah.
you guys.
Thank you. See you.